The other student join the class. Let's see what we have discussed in the last class. आप लोग को स्क्रीन दिख रही है? Okay. So in the last class we have discussed about window to viewport transformation or view pipelining. So here we have any object in our world coordinate system or actual what we have seen in the world, and we capture the portion of the object what we want to take, or in the area we are interested. Suppose we are taking a picture, so when we take a picture we select the particular area, which area we have selected, what we want to capture. Okay, suppose there is a person is standing in front of you and you want to take the picture of only 2%. So what you will select? You will select those portion where that two persons are in your window. What you've seen in screen. Okay, so the window is actually that portion or the area. The window, as you can define, area selected in the world coordinate or display is called a window. It is defined what is to be viewed. It's what you want to see. Okay, so you have selected those area what you want to see. Okay, in the viewport, as you can define, area on a display device in which window image is displayed. Means after taking the picture, the portion is transformed into your screen, mobile screen or computer screen. So this viewport is actually the visible area of your device, and this is your device coordinate, and your device coordinate, this is your viewport where your actual image is displayed. Okay, so this transformation from window to viewport we have discussed. So this window, not always a rectangular or square, it can be any kind of shape. Okay, so in many cases window and viewport are rectangle. Generally we use the window or viewport as a rectangle. Also, other shape may be used as a window or viewport. In general, finding a device coordinate of viewport from world coordinate window is called viewing transformation. Or sometimes we also call this window to viewport transformation. We capture the particular area what we want to display, and the viewport you can define as where is to be displayed in the device. Is it clear to all of you? Okay, so this is our word coordinates, and this is our device coordinate. And this word coordinate, we have selected this window, and we give the boundaries of this window. We have defined the boundaries of the window as like this. This is our x coordinate, and here x wx mean is the minimum of x coordinate, and here is the maximum of x coordinate, and this is the boundary, bottom boundary of your window is y w min, and here is the above is the upper boundary of your window is y w max. So here we are defining the boundaries for our windows. This is our window. The same, you can define boundaries for your viewport. This is your device coordinate, and you are defining the boundaries of your viewport. This is one. This is one boundary. What is the coordinate of this boundary is where x v min, and here as you can see x v max. As the same way there is a four boundary, and what is the object which is inside this only we consider. What are the object which is outside we just click or remove. So this is all about window and viewport. Now we will transform this window what we have captured. Here we have captured this area, and now we want to transform this area into a device. So we've discussed the question how we will transform. So this is the procedure of transformation. Window to view transformation. Mapping of window coordinate to viewport is called window to viewport transformation or viewing transformation. To this, we use using the transformation to maintain the relative position of window coordinate to viewport. The main thing is the relative position should not be changed. Here, what is the position of your object in the window? Same position should be remain into a viewport. Okay. But the size or the shape of window may change. Suppose the window is the size of your window. When you transform to your viewport, maybe your window or viewport or device window is like this, a square, but your windows is a kind of rectangle. But the position, relative position of your objects should not change. Suppose your object in window is here at the right side bottom, so the same should be here in the viewport. The relative position of the boundaries should not change. So how we can transform using this formula we have discussed. Okay. When we simplified, we will get the xv is the view coordinate, device coordinate for x is formula, and here for the device coordinate for y is this, and here your xy, and we have defined what is the value of xy. So this all this we have discussed. Transformation from window to viewports. Okay. Now the next is it clear to all of you? If you have any doubt, you can ask. If you have any doubt, you can ask. For everything it is clear. For this kind of transformation, we have also discussed one example how we can transform. Okay. So the main question is now raised is this is your window, as you can see on the screen, and then this is an object we are this is object we are interested object area. Okay. Now the portion of the object which is outside, this portion which is outside, this portion this is outside, and this portion is outside. What we have to do, we have to clip. Means we are not interested in this portion of your object. Okay. So what you will do, you will clip. Okay, or cut. Clipping is the process of removing the unwanted portion of your object. This is the meaning of clipping. Clipping means clipping is a process of removing unwanted area of your object. Here, as you can see, this area of this object we are not interested. Here, the bottom area of this object we are not interested. And some portion of this area we are not interested. So, how we can clip? Okay, so now we will discuss our next topic is clipping. After selecting the particular portion of your object and what the area of your object which we are not interested to consider, we have to clip. So you can define your clipping as any procedure that identifies the portion of image that are either inside or outside. Suppose this is your clip window and this is your object. Okay. So you can define that clipping is the a procedure that identifies those portion of a picture that are either inside or outside of a specified region. This is your specified region. What we call it, we are calling this specified region as a window. This is defined as a clipping algorithm, or simply we can call as a clipping. So you can define your clipping as a finding the portion of image which is inside or outside. If it is inside, just consider it. If it is outside, just remove it or discard. So this window you can define the region against which object is to be clipped. It's called clip window. This window we are calling as a clip window. Here this is our clip window and this is our object, and this object we are not interested, so we are removing it. Is it clear? Okay. So one minute. Let me show you one video. The song, I think you heard this song. Again, I have clipped one particular portion of a song. Means I just clip what I am interested to show you. Here, this is the video. You can heard this song. Again, I'm playing this video, and in this video, as you have seen, this is your object. This is your object, and what he has done, he just clipped. Clipped here is it's clipped window as a circle, and what the portion he is interested in just consider, and the remaining portion which is outside from your clip window it's removed. Okay. So again, let's back. See again this video. Okay, so what we are doing, we are just clipping a particular region of your object, and the remaining portion which is outside from your particular uh, clip window, we are just discarding. It is depend. So the your clipping window may be a rectangle or a square or any kind of shape. There's not straightforward to always your clip window is a rectangle. Okay, it can kind of any shape. So in the clipping, first we will see the point clipping. In the point clipping, we see your point is outside or inside your clip window. If it is inside, we will just consider for display, and if it is outside from your clip window, we will just discard or remove from your device. Okay. Then we will discuss about the line clipping. We will see the line. The line is inside or outside from your clip window. If it is inside, we will consider. If it is outside, we will remove. Or it may be partial inside and some portion of your line is outside. So what the portion which is lie under your clip window, we will consider only those portion, or we will display only those portion of your line on your screen. So the third is polygon clipping or area clipping. In the polygon clipping, we will again see the area which is inside or outside your region, or clip window. If it is inside, only those area we will consider for displaying, and those area which is outside from your clip window we will just discard. Curve clipping, the same way we will see the curve, what the portion is inside or what the portion which is outside of the window. And next is text clipping. We will see the text which is inside will display. If it is not inside, we will just discard it. Okay. So this was the clipping we will discuss. Okay. So the first start with point clipping. Point clipping. For the point clip, just assume your clip window is a rectangle. Just consider our clip window is a rectangle, and we have a given point P, and the coordinates of P are just consider X and Y, and we have a one clip window. Suppose this is your clip window, and the boundaries of your clip window you can define as this is your XW min, and here it's XW max. This is YW min, and this is YW max. This is your clip window, and these are the equation of your boundaries of your clip window. And now we have to find this point, check this point which is inside or outside your clip window. For checking this point is which is inside or outside, we have four inequalities condition. These four inequalities conditions should be satisfied. The first one is your value of x should be greater than equals to value of XW min. First condition should be satisfied. Your value of x should be greater than XW min. It means it means your point should be in from this. It should be here in this direction. Okay. And second condition is your x should be less than equals to XW max. Means it should be in this range. It should be between XW min to XW max. Third condition is your y should be greater than equals to YW min, and your y should be less than equals to YW max. Let's check the value of y should be between this YW min and YW max. So for considering this point for display, all these four conditions should be satisfied. If all these four conditions satisfied, then only we will consider this point for display. Okay. When all these four equalities conditions are satisfied, then only we will consider this point pxy for display. Otherwise we will discard this point for display, or we will not consider this point for display. Is it clear? For checking a point which is inside or outside your clip window, we will check these four conditions. If all these four condition inequalities condition are satisfied, then only we will consider this point for display. Otherwise, we will discard this point for display. This is the simple for point clipping. Is it clear? Is it clear to all of you? Okay. So let's move to our next clipping. Next, our next clipping is, sorry, line clipping. When we call this line, just consider it's a line segment. When we call line clipping, just consider it is a segment. Okay, we're talking about segments. So in the line clipping, we have again given a clip window. We have again given a clip window. For this case, just consider your clip window is a again a rectangle. This is your clip window, and we have many lines, or one line. Suppose this the line is this line. Okay, put something here. One line is just considered here. Just consider this like this. Just consider this. So here there are many lines. Line number one. This is just consider this is line one, and we will check this line is inside or outside. If it is inside, we will consider, otherwise discard. As you can see, this line segment is completely outside. So what you will do, you will just discard. And here, as you can see, this line segment 2, which is inside, then you will consider for display. Here line 1 we will discard, and line 2 we will consider because it is inside. As you can see on your, and if we talk about this line, is the some portion of your line segment is inside and some portion of your line is outside. So what you will do, you will consider only these portion for display. Okay, and the remaining portion of your line you will discard. Okay, this portion only you will consider for display. The remaining portion of your line you will just discard. If you talk about this line number 4, here this portion of this line is only inside your clip window, and the remaining portion of your line is outside. Okay, and in this case line number 5 is completely outside. So the way or the procedure in which we find the line which is inside, we check the condition is inside. If it is inside, just consider, as you can see in the case number 2, we will check for the line clipping algorithm. We are going to check the condition, some condition. First, check it is completely inside. Check it is completely inside. If it is completely inside, just consider for display. Or in other words, we can say accept. Okay, if it is completely outside from your clip window, then as you can see, this line number 1 and line number 5 is completely outside. So what you will do, you will just reject. So first we check it is completely inside or completely outside. If it's completely inside, just accept it for display. If it is completely outside, just reject. Do not consider for display. Check condition third. It's partially inside. If it is partially inside, as you can say, like case number 3, some portion of your line is inside. So what you will do, you will just apply the clipping operation. So you will clip. So in the case of line 3 and line 4, in this 3 and 4 we need to clip. So we apply the clip operation. So you have always 3 cases: accept it means completely inside, reject it completely outside, and if it's partially inside and some portion of your line is outside, you will apply the clipping operation. So the algorithm which find these 4 conditions, it's called the clipping algorithms. Okay. So using clipping algorithm, we will find the line position. It is inside, outside, or it needs clipping. Is it clear? Is it clear? You can unmute your mic and speak. So the first algorithm,
Yes.
okay, okay. So the first algorithm we are going to discuss for the clipping of line. Line clipping is Cohen-Sutherland. So the first algorithm we are going to discuss about line clipping is Cohen-Sutherland line clipping algorithm. This is the one of the oldest line clipping algorithms. In this line clipping algorithms, we have just in this line clipping algorithm, every endpoints of line we assign a 4-digit binary code. Just first draw the region or clip window. Suppose this is your clip window, and this Cohen-Sutherland line clip algorithms. Every line segments we have given every line segments endpoint. We have given a 4-digit binary code that identifies the location of point that identifies the relative position of your endpoints to your this clipping window. If it is left side of your this clipping boundaries, we will give the 1 bit for the left, and if it is right, let's see, we are giving this right 4-digit. We are giving a 4-digit binary code for each endpoints of line, and these binary code identifies the location of your endpoints relative to your clip window. And we have used this method ABRL. Here A is above, if your endpoint position is above your clip window, we will set this bit as 1. If it is not above your clip window, the value of your binary code for this point is 0. If it is below to your clip window, if this endpoints is below from your clip window, in this area, in this area, we will give as 1. If it is not below from your clip window, it's set as 0. Okay. If it is right side of your clip window, this endpoint is right side. This is your boundary of your clip window, and it is reside in this area. Then this bit is 1. If it is otherwise, it is 0. And L is right left. If your point relative position of your point from your this clip window is left, then this bit is 1, otherwise 0. Just now let's consider one point. Let's see, we're talking about this point P1. Now let's set the position or the give the 4-digit binary code for this point P1. Check it is above your clip window. No, so we'll set the 0. The first bit is 0. Check it is below from your clip window. No, it's not below from your clip window again. So the second digit is also 0. Check the third bit. It is right side of your clip window. No, so again 0. And check the fourth condition. Is it left side of clip window? Yes, so we will give 1. So this is the code for this point P1. So again, give this region with certain codes. If it is this point is inside your clip window, means it is not above your clip window, it is not below your clip window, and not is it is right side of your clip window, and not even it is left side of your clip window. So the region code, when your point is inside your clip window, the code is 0000. Okay. If this point is in this area, this region, so the first is it is above. No, so set the first digit 0. It is below. Yes, so set the digit 1. It is right. No, so set the digit 0. It is left. No, so set the digit 0. The same way you can set from this region. It is above. No, it is below. No, it is right. No, it is left. 1. Yes. The same way it is above. No, below. No, right. Yes, and left. No. Here it is above. Yes, it is below. No, it is right. No, it is left. No. The remaining area, this area, it is above. No, it is below. Yes, it is right. Yes, it is left. No. Here it is above. No, it's below. Yes, it is right. No, it's left. Yes. Here the code is above. Yes, it's below. No, it's right. No, it's left. Yes. Here it is above. Yes, it's below. No, it's right. Yes, it's below. Sorry, it's left. No. So these 4-digit binary code we have given to each endpoints of line where it lies related to your clip window. Is it clear to all of you? Okay. So when you have given all this region code to each point, we will apply some operations. Or check the condition, it is inside or outside of your clip window. Okay. Now using this Cohen-Sutherland line clipping algorithm, we will see some cases for checking it is inside, outside, or partially. Ultimately for the line clipping, we do this. We find these conditions: this completely inside, or completely outside, or partially inside. Okay, if it is completely inside, accept it. If it is outside, reject it. If it is partially inside, so we will click. So the first case, let's see the position this line. Just consider this line, line P1, P2. Okay. So check the condition for P1 and P2. Line P1, this line and the endpoints of this line are P1, P2. What are the binary code for point P1 and endpoint P1? This, so the binary code for this point is 0001. And what are the binary codes for point endpoint P2? It is also 00001. So in this algorithm, we will apply the AND operation of these two endpoints, logical AND. And when you apply the logical AND, 1 and 2, 1, 1, 0, 0, 0, 0. So when your endpoints is non-zero, and the second point is also non-zero, and end of these two endpoints are also non-zero. Again, I'm just repeating. When your endpoints are non-zero, non-zero, and end logical end of these 2 points are also non-zero, we will reject that line to display. Okay. When these endpoints are non-zero and after applying the AND logical AND and also get the non-zero value non-zero, we will completely reject this line for display. The P1 and P2, whether this line is, we will not consider. Okay, simply we will reject. Check the case 2 when your point or one line is like this. Just give the name or give the endpoints P3, P4. In this case, P3 and P4. Sorry, P3. The endpoints of binary code for point endpoint P3 are 0000, and binary code for point P4 is also 00. Apply the logical AND and you will get 000. It's a 0 and it's 0 and end of is also obviously 0. So when we have endpoints are 0 and 0 and the end operation is also 0, so in this case we will accept this line or completely consider this line for display. Is it clear? When your endpoints binary code of your line are 0 and other point is also 0 and applying the end operation you will get the 0. So in this case you will completely accept the line for display. Check the third case. Let's consider this line is this P5 and P6. Check. Check the P5 and P6. P5, the code of P5 is 0000, which is inside, and code binary code for point P6 is 0100. Apply the logical AND and you will get 0000. This is 0, this is non-zero, and this you will get 0. When one end point is 0 and one another point is non-zero, and after applying the AND operation you get the 0 value, means your some portion of your line is inside and some portion of your line is outside. So what you will do means in this case your partially inside. Your line is partially inside. When your line is partially inside or some portion of your line is inside, you will apply clipping. In this case, we will need to apply clipping. In this case, we will clip. For the clipping, how we will apply the clip? We will find the intersect point where it is intersecting with our clipping window's boundary. As you can see, it is clipping at this point. It is clipping at this point. So we will find this point. It is, just give the one name. Just give the name P6 dash. Okay. So we are clipping this point, this line at this point. We will find this intersect point and clip this line from this end point. Okay. So the new line is P5 and P6 dash. Now the let's see the code of P5 is this 0000 and P6 code is also now 00 because now it's inside or on the boundary. When your line is inside, sorry, the point is inside or it is boundary, the code is 00. Apply the logical and you will get 00. So the it's non-zero. It's, and the second point is also non-zero. And after applying the end, you are getting the non-zero. So you can see the first case when both the point is non-zero and after applying the end, and it's also sorry, it's a zero. It's not zero, it's a zero. Sorry. It's a zero. This is also zero. This is also zero. So both the endpoints are zero, and after applying the end, you will get to zero. So in this case, you will accept the line. In this case, you will accept the line. So this portion of your line, you will accept it. P to P6 dash. The remaining portion here clipped. So I'm just ending this meeting right now and again starting the new meeting. So please join again. Please join again this meeting.